Hey there, Mr. H here again, talking some probability. This is page 7 and the chapter 3 notes. Still on 3.1. Now we're doing a new example about cards. So playing cards. Some of you are familiar with playing cards. Some of you probably aren't. You may have never seen a deck before. That's okay. That's why I have this graphic here. But all of the questions about cards are going to be based off of this graphic. It's a standard deck of playing cards. It contains 52 cards, and there are 13 cards of each suit. So a suit is the image you see on each card. There's the clubs, that's the first one. All right, so these are the clubs, and then we have the spades and the hearts and the diamonds. Okay. The clubs and the spades are black cards, and the hearts and diamonds are red cards. And then within each suit, there are values on the cards. There's 13 of each one, and it range from an ace, which is kind of like a 1, I guess, and then 2 through 10, right? That's the numbers. And then you've got Jack, Queen, King, which are the face cards. So, it might be worth getting yourself a deck of cards to get familiar with it if you're not already, or use this image when you're answering questions about the cards. I'll refer back to it when we answer the questions below. But it's a nice way to demonstrate some concepts and probability. So that's why we're using playing cards. Okay. And one of my favorite hobbies is poker. This is kind of up my alley here. I do use a lot of probability and statistics when I play poker. So let's try some of these out. If one card is selected from the deck at random, find the probability that, and it just says write your answer as a reduced fraction. All right, so we're just going to go fractions. One card we're selecting from these 52. Right? What's the probability that we get blank? So number 18, what's the probability that the card is a 7? All right, so let's practice that probability notation. Probability of getting a 7. And I'm going to write a fraction. Now remember, there are 52 cards, so the denominator's got to be 52. Right? It's the total number of possible selections. Of those 52 cards, how many have a 7 on them? Right? Well, there are the 7s right there, right? So I see 4. Right? There's 4 7s. So I'm going to write 4 here. And then I can reduce that. 4 does go into 52 13 times. So that's 1 over 13. Okay. Next one, the probability that the card is a heart. So let's go probability of, let's just draw a heart. Probability of getting a heart. Okay, so let's erase what we got up here. Where are the hearts? Hearts are a suit. All those cards are hearts. So there are 13 of them, and we're still pulling from the total of 52. So this would be 13 over 52, and 13 divides into 52 4 times, 1 over 4. Okay. How about the card is red? All right, well, anything that's a diamond or a heart is red. So that's 13 and 13, that's 26 cards, right? So the probability that the heart is red, 26 over 52, which reduces to a half, or half of the cards are red. You have a 50% chance of selecting a red card. How about the card is a 7 or a heart? Okay, probability of 7 or heart. Well, I already know the bottom number. It's 52. That's no surprise. I just have to count up how many cards are either a 7 or a heart. I got to be a little bit careful here. So let's see if we can highlight them. Here's all the hearts. I'm going to count up all those. And here's all the 7s. I'm going to count up all of those. Careful, because one of the cards I highlighted twice, namely the 7 of hearts. Just careful not to double count that, right? So I have 13 hearts, and then 1, 2, 3 more 7s. So that's 13 plus 3, 16. Or I just highlighted 16 cards, right? There are 16 total cards that have that property. Okay, ooh, do I have to reduce that? So let's see, what goes into both of those? 4, divide each of those by 4, and I'll get 4 over 13 for my final answer. Okay, how about the card is a 7 and a heart? So little details here, or versus and, which we will get to in these future sections. But the card is a 7 and a heart. Well, I only see one, right? That's the only card that has both a 7 on it and a heart on it. So there's only one out of 52. Okay, probability of 7 and heart, 1 out of 52. Hey, a simple event, right? Because there's only one way to pull the 7 of hearts. Okay, the card is not a diamond. So probability of not diamond. Not a diamond. All right, I go back up to my list. I could just see what cards are not diamonds. Well, all of these are not diamonds, right? There are 13 diamonds down on that last row. So, and there's 52 total cards, which means there's a total of 39 non-diamonds. Right? So I'd go back to problem and write 39 out of 52, which I think both of those are divisible by 13. So 3 out of 4. Okay, the card is a face card. Face cards have faces on them. That's all these guys over here. So I just highlighted all the face cards. Looks like I'm counting 12 of them. So that's 12 out of 52. So probability of face, 12 out of 52. I think both of those are divisible by 4. So 3 out of 13. Final answer. Whew. Okay, that completes 3.1. That's the last video or last page in the series. Try that homework out now, see how it goes. Any issues pop up, let me know, and we can go from there. Okay, hope everything's going well. Talk to you later.